We've talked a little about the difference between working with a full population of data and working with a sample. In most real-world scenarios, you won't have access to the full population. For example, you're unlikely to have rainfall measures for every day ever. And even if you did, that's a lot of data to try and manage. Generally, you'll work with samples of data that are representative of the data. And you'll use sample statistics, such as the mean and standard deviation, to approximate the parameters of the full data population. Let's suppose that the full population of rainfall ever looks like this. The distribution is right skewed, indicating that most of the time there are low levels of rainfall, but there are a few days in which there are extremely high amounts of rain. The mean daily rainfall is 0.83 centimeters. Now let's suppose that we take a random sample of daily rainfall values. The distribution for our sample might look something like this, with a sample mean of 0.89, close to, but not exactly the same as the population mean. Now let's take another random sample. This time, the sample distribution looks like this, with a sample mean of 0.97, quite a bit higher than the population mean. And if we take a third random sample, we might end up with a different distribution and a sample mean like this. So what can we do to ensure our sample statistics are truly representative of the full population parameters? Well, up till now, we've used fairly small sample sizes. In practice, it's best to get as large a sample as you can. The larger the sample, the better it will approximate the distribution and parameters of the full population. Another thing you can do is to take multiple random samples. Each sample has a sample mean, and you can record these to form what's called a sampling distribution. With enough samples, two things happen. One is that, thanks to something called the central limit theorem, the sampling distribution takes on a normal shape, regardless of the shape of the population distribution. And the second thing is that the mean of the sampling distribution, in other words, the mean of all the sample means, will be the same as the population mean.